A over
Oh, wait a minute, you're getting too complicated. AX hat dotted into BX hat. I mean BXI hat. Let me say it again. AXI hat dotted into BXI hat.
A, B, X, I hat squared. If you're multiplying them all together, is there just normal multiplication rules? And
Let's
G
do it again.
is a variable?
What's the length of this in the direction of this?
Same direction, so it's,
A cosine theta.
so that's
AX.
Yeah.
Yeah.
Cosine of theta. Theta is 0. I hat and I hat have the angle between them is 0, right? So if you like mathematics, cosine of 0 is 1, right?
Yeah.
If you like physics, they're going in the same direction. Okay? So this dotted into that is just AX BX, right? AX BX. Write it down. AX
Don't you still need I hat to denote direction?
I hat denotes direction, but remember this is a scalar product. It has no direction. The answer has no direction. It's a number.
Why is the product of two vectors scalar?
Okay? You asked a why question, which in physics is generally the perfect question to ask. But this isn't physics, it's mathematics. Why? Because some dude or some woman decided to do it this way. It's a convention. In other words, when you say I'm going to multiply these two vectors, you might say, well, why did they pick that way? Well, they might have picked 100 different ways, but those ways didn't survive. Why did this way survive and those didn't? This proved useful. This proved useful. I had a lot of ideas in life. When I was in grad school, I had what I thought were some great ideas. Nobody uses them. I got one, by the way, they're going to use. It's unbelievable. But the thing is, this idea survived because it's useful. It turns out to be very useful, which you haven't seen yet because you haven't learned physics yet. But right now, don't ask me why. Someone decided to do it this way. But I love the why question. But for now, this is just mathematics, okay? All right, so I get AX, BX from the first term. You do the second one now. What's AXI hat dotted into BYJ hat? What do you get?
0.
0. Who said that? How do you know it's 0?
Because they're perpendicular.
Perpendicular, they don't project the way Hitta talks. There's no projection of A onto B. So that term 0.
Oh, yeah.
What's this term? AXI hat dotted into BZ K hat.
0.
0. These three vectors are orthogonal, right? Well, they keep going. You get another term here, right? This one produces a term. What is it? Plus AY, BY. And the only other term that's going to survive is AZ,
That's cool.
BZ. So here's another way to write A dot B. Okay, but what's the direction of it? That's the number. What's the direction?
There's no direction.
There's no direction. Why isn't there a direction?
To the scale.
Well, that's a tautology. Why is it a scalar?
Because somebody said so.
Because someone said so. This is what I'm going to define as a dot product. If it's not useful, it'll never survive. But you're going to see it's very useful in physics. You'll see that as we come along. So now we have two ways to find it, and this is very nice. If, depending on what you're given, you might want to use this one or you might want to use this one. If you're given the two lengths of the vector and the angle between them, you're going to use this one. But if you see the components of them, you might want to use this one. And if you want to find the angle between the two of them, you might calculate it this way, set it equal to this, and you can find the angle.
How do you find an angle in the z direction?
How do you find an angle in the z direction? Is that the question?
Yeah.
Okay.
You ran the plane.
Depending on how deep that question is, I'm not sure how deep it is. I think I'm going to try to answer it the way let me try this first. Let's do this. If I said to you, oh yeah, let's try this. A and B. If I say to you, what's A dot B? Answer? What is it? I'm looking for a number.
What did you say? It should take AB cosine
A dot B, what's the answer?
2.
No.
theta.
I was thinking like based on the grid.
Yeah, based on the grid.
Oh, 6.
6.
What?
Oh, yeah.
Because A
And cosine theta is
in the direction of B, you got to see, is 2, right?
Yeah, I got it.
times the length of B, which is 3. 2 times 3 is 6.
And cosine theta, because it's 45 degrees. No, why, what happens to cosine theta?
Okay, this here, this part right here
Yeah.
is, remember we're defining this as theta, right?
A cosine theta.
That's A, right, well, A cosine theta is the green line.
Yeah.
But it's 2, I can look at it and see it's 2.
Oh, cool, okay.
Now, I'm taking advantage of the fact that this is calibrated already, right? So that part is 2, and the length of B, well, that's 3. Now, suppose I wanted to know the angle between these two. Of course, there's a lot of ways to do it, but using my definition here, I know that this is equal to, well, let's do it like this. A dot B is equal to 6, right? But that's equal to A, B, cosine theta. Now, let's put in A. What does A equal?
Two over.
2 root 2.
2 root 2, right? Or the square root of what? 8. 2 root 2. What do I put in for B? 3. This equals 6. And now I can find the angle between them. Now, what does it got to do with the z direction? You can call any direction you want the z direction. There's no problem. But what I think you're saying is how do you take the dot product of 2 vectors that have 3 components to them? Is that really what you're saying? You can still do this, but it might, depending on the problem, it might not be so easy to say what the length of A and B are. I have a little exercise for you. I'm not going to do it today where you need to do this. But you can do it just like I did. You can always do it mathematically just like this, but then you got to have all 3 of these filled in, not just 2 of them. It still can be done mathematically. I'm not sure if I...
It's not just AB cosine, right?
It's just AB cosine theta,
Probably is.
but, okay, let's talk about 3 dimensions. I hate to do this because I like to teach you the math in the context of physics. I'm kind of just a review here, but let's just do a little bit here. So we'll say that this is the x direction. This is the y direction. This is the z direction. Right? This is the z direction. Now, if I have 2 vectors with pointing any old way, okay, I still can say what the length of A is. To get it, I'm going to have to do ax squared plus ay squared plus az squared, square root of that, right? That's going to give me the length of this. And then I got another vector maybe pointing out this way. Again, I can get the length of it again. It's ax squared plus ay squared plus az squared, the square root of that. And now I can find the angle between the two. See, 2 vectors that point out like this. They're still going to have an angle between them. A, B cosine theta, I can still find the angle between them. It works in 3 dimensions. It works in 16 dimensions. If you want to. Quantum physics is one theory of quantum physics. You have to imagine 16 dimensions all orthogonal to understand it. The mathematics still works. But I'll let you know that in this course we're going to limit it to 2 or 3 dimensions, so you don't get into it. I'm not positive I answered your question, but I'll say the answer simply again. Same strategy will work, no matter how many. Okay, that's a review of the dot product. We're going to the cross product now. And we had said, oops, let's do it like this. Let's talk about conceptually the cross product now. Conceptually, it's the area swept out by the 2 vectors. So A cross B, written like this. A cross B. Conceptually, its magnitude is the area swept out by the 2 vectors. You know that word swept out? The parallelogram created by the 2 vectors. You got what I'm talking about? So if I did A cross into B, then the area swept out by the 2 vectors would be this area. Right, that's what I'm talking about.
Can you make it as big as you want?
As big as you want?
Yep.
What do you mean? That's a parallelogram.
Just make the parallelogram as big as possible. How are you measuring that area?
What do you mean? You attach it to each of the heads. Like,
So
Like,
you-
do you
oh,
have
okay,
the
I'm thinking- I'm
length?
thinking raised, never mind.
Okay, now, yeah, this vector, well, this can be, well, you can put it up there.
Yeah, I know, I got it, actually.
So when I say the cross product, the magnitude that I mean is the area swept out by the two vectors. Which changes, right, depending on the angle. But that's not so bad. Let's see what that is. The area swept out by the two vectors. Well, if you remember the formula for a parallelogram, you got to get this here, right? It's the base times the height.
Mhm.
But if I call this theta, then what is this in terms of A, B, and theta? What is this side? A sine of theta. Very good. And so then, to get the area of this, it's A sine of theta times B. So we write this A, B, sine of theta. That is the area swept out by the two. But this is a vector quantity. It's also called the cross product or the vector product. It also has a direction, which is a little confusing. Again, it's just a human convention. To get the direction, first thing I want to say is the direction is always, can I use the word normal? You know that word normal? Or orthogonal?
No.
Perpendicular? Okay. The plane, two vectors form a plane, right? Anytime you have two vectors, they form a plane. The direction of the cross product is perpendicular, I like the word orthogonal, to the plane. Now, so let's say I have two vectors. Here's one right here, here's one right here. Well, the cross product is going to equal the area of the desktop, right? It's the magnitude. But what's the direction? It's got to be perpendicular to the plane. Now, is it that way? You all right?
Oh, this chair is weird.
I hate this chairs.
I've noticed all period you've been distracted by that chair. There's two levers on the chair. Should I explain the chair?
I don't know, it was just going back and forth for some reason.
There's two levers on the chair.
You
One
have to set the level, yeah, I think one of them-
determines the tilt, the other determines the height.
I like them. They're really like, I don't know.
What's not to
it's
like?
rocket science.
Not to like.
Yeah, they're awesome.
This is
Okay.
smarter than this.
I get so distracted so easily.
All right, Leon, you cost us 30 seconds.
I'm sorry.
Now look,
Why does it have a direction?
Wait, but is it up?
why is the dot product the way it is? Because somebody decided this would be useful, and they were right.
What is it used? Like what?
Well, we're going to get into it, but you know about torque, right? Torque is a cross product,
Oh.
right? And we'll learn a bunch of other things too.
Oh my goodness.
Okay, so you guys last year learned about things I never formally learned the mathematics of it, but you're going to see that the things you learn can be described by these things. Okay, so the vector A cross B, its magnitude is the area of the tabletop. That's clear?
Yeah.
But what's the direction? That way. Or is it that way? How do you know which it is?
Right hand and
With
left hand.